Okay, this is example 1, and we're continuing 7.3, which is solving systems of linear equations. On Friday, you solved them by graphing, so now we're gonna use an algebraic method of solving these systems. So I'm just gonna write the same system that you have on your ICA, which is the first equation is 2x minus 3y equals -4. And the second equation is 2x plus y equals 4. And we actually already know the solution to the system, right? If you graph these two lines, which you should have, this would be the solution, right? 1, 2. That's where the point of intersection would be. So what if we didn't want to graph this? We could solve this, right, by using algebra. And one of the methods is called a substitution method. So let me write that. Substitution method, right? So we're going to substitute for a variable. So remember, this is, right, if you want to call it line 1 or equation 1, and this is line 2. So the first step in solving the system by using substitution is you want to pick an equation and then solve for a variable. So pick an equation and solve for a variable. So I'm going to go ahead and pick equation 2. Okay, so I'm going to write my equation down. Let me just move this up. Okay, so I'm going to solve for a variable. Now, because my coefficient in y is 1, I'm going to solve for y just because it's a little bit easier. If you want to solve for x, that's fine as well. It's not going to be wrong. So if I solve for y, so solve for y. I hope you can read this. Sorry, I'm doing this in the car while driving. Well, I'm not driving. Okay, so if I solve for y, or if I subtract 2x from both sides, right, I get 1y, or y, and y equals 4 minus 2x. Okay, so I'm just going to go ahead and circle this part. Once you've solved for one variable and one equation, well, now I'm going to substitute. So I'm going to maybe circle this in blue. I'm going to substitute this guy into the other equation. So this is equal to y, so I'm going to substitute it right in there, right? Make sure not to substitute it back into the same equation. So let's go ahead and do that. Let me just make this a little smaller. Okay, so we have 2x minus 3, but what's y? Well, it's 4 minus 2x, right? This is my substitution. And that's going to be equal to -4. Okay, so now we have a nice linear equation and one variable, right? This should be familiar from chapter 6, right? This is a linear equation, right? We have some distributive property to do. So we have 2x, and if I distribute -3 times 4 is -12. -3 times -2x is positive 6x. Okay, make sure that negative times a negative gives you the positive, because there was quite a few mistakes on that on the test. Okay, so if we continue solving this equation, okay, so we've removed the parentheses, so can we combine like terms? We can. We get 8x minus 12 equals -4, right? We're isolating x, and I get 8x, right, equals, right, 12 minus 4 is 8. So 8 times what is 8? Well, it's got to be 1. So x is 1. which makes sense, right? Because our solution from graphing, it was 1 comma 2, right? And notice x is 1. So we know what y is going to be, but I mean, assuming we don't, because you don't have to graph it all the time. So let's go back down and do the last step. So if x is 1, oh, let me just get this arrow. So if x is 1, now now back substitute. Okay, in other words, substitute back the value that you just received. So you have, so again, x comma y. So you found 1. Well, now your goal is to find y. So we can substitute this 1 back into any equation you'd like. Whoops. So if you pick, I don't know, let's pick maybe the first one. So 2x minus 3y equals negative 4. 2x minus 3y equals negative 4. And I'm just going to plug this guy right back in, right? So 2 times 1, right? And now I have an equation in y. So 2 minus 3y equals negative 4. And move this up. And I can subtract 2 from both sides. And when I do that, I get negative 6. And then we have, we can divide by negative 3, right? Because we want a 1y. So y equals 2. So x is 1 and y is 2. So that means they should intersect. The solution should be at 1 comma 2, which is what we did obtain in the last, in the example by graphing. The way to check this is you do the exact same thing, which you already have on the first example. You just substitute the values to generate 2 true statements. Okay, so this is substitution by, this is solving a system using substitution.